Hi everyone. With the wonderful new ways of working, I apologise for the background noise. But today's speaker, Jon Rees, is a Principal Oceanographer at the Centre for Environment, Fisheries and Aquaculture Science. His talk today is about the Department for Environment, Food and Rural Affairs and the Marine Management Organisation fund that funds the emergency response advice for the case of oil and chemical spills and the use of dispersants in the marine environment. One of the tools used is numerical models to predict the trajectory, concentrations and potential landfalls. Over the last 10 years, Jon has used 3 models to predict the landfalls of missing persons once the Marine Coast Guard Agency have stood down their own teams. Jon will talk about the challenges and a potential solution and in a number of case examples. So thank you, Jon. Over to you.
Good afternoon from a very sunny Suffolk, so I shall just carry on and plough into this particular talk. You may be in the UK or all over the world, so apologies if you come from a different time zone. Now, this could be a potentially sensitive subject to some ears, so I've taken out as many of the contentious issues in this particular talk. And I apologise if I bring to the forefront issues that perhaps you've not thought of before, but please accept my apologies in advance. So first of all, Seefast, as Gemma has just said, Seefast is a world leader in terms of marine science and providing innovative solutions for a variety of different users. We provide advice to UK governments and governments all over the world, especially in places like Kuwait and Oman, where we have offices there providing advice to their own different users in that location. So, how did Seefast become involved in forensics? Well, Seefast provide advice 24/7 to DEFRA, the Marine Management Organisation, Food Standards Agency and the MCA on the potential impacts and trajectory and landfall of oil and chemical spills. So this has been going on for many years and is established procedure, and we provide advice in terms of the use of dispersants in these particular areas. So other emergencies include the loss of containers, surprisingly frequent events even in UK waters. Wood slick, so that was a cargo that had lost its slick, lost a deck load of wood. Dead swans, this is about 10 years ago, where a swan washed ashore with H5N1, perhaps a little precursor of what COVID-19 has been doing. And that washed ashore on the Scottish coastline, and the landfall location was established pretty quickly, but the scientific advisors wanted to know where it had come from. So we did some work backtracking along those particular lines and identified that in that particular case, the swan had most likely died in the central North Sea and then just been washed ashore. So other areas and track record that we work on, quite a lot of these are large incidents that are fairly well known. So the Brer that went aground in the Shetlands, the Sea Empress in Milford Haven, and also some expert witness cases, the Ethos 1, which was an oil tanker that went aground in Pakistan. So we provided advice there. One that has provided lots of work over the years and has, spun off a whole series of projects is the impact of the MSC Napoli, a container vessel that went aground, well, was pushed aground in Lyme Bay, and it had 2,318 containers. That's on board, and some of those had highly toxic substances on it. So those were identified and prioritized in terms of removal from the wreck. In terms of those emergencies, I mentioned the Fife, the dead swan, the wood slick. Other ones include the Osaka in Southampton water, and finally some the forensic oceanography, which I'm going to talk about a little bit more today. So that's how we got into this area and what we've been working on. So there are, in terms of forensic oceanography, there are various types of requests. So we get involved in search and recovery requests. So that's different from search and rescue. So that's where the MCA will be leading the charge in terms of trying to recover that person and rescue that person, whereas we get involved in search and recovery aspects. And it's surprising that we actually get involved in these on about a fortnightly basis. There's quite often 1 or 2 cases still rumbling on at any one time. So these will be all sorts of cases. So as I said, the first type is a post MCA incident. So this is perhaps a ship that's gone down, a lost person from the who's been washed off a foreshore or something like that, and they will have their own search and recovery operations. So that they will use a program called SARSIS to try and find the individual. We get involved when they've stood down their search and rescue operations. Other types of incident are where the police themselves start the search operation. So that may be, for instance, when somebody who has potentially attempted to commit suicide or has been in an incident, a chase or something, and they have jumped into the water. So these occur fairly often. We also get in terms of looking at backtracking, so trying to identify the source of where bodies or narcotics have entered the water, and using the position where they're found to backtrack to that entry location. And finally, we get involved with cold case reviews with looking to identify potential people who have been lost on, for instance, the East Anglian coastline and have been found on the Netherlands coastline or the Belgian coastline. So, starting from this is the overall challenge. So this is where I start from, and this is, what I've tried to do here is go through the whole series of the challenges, and this is all from an oceanographer's point of view. So first of all, we've got to identify and characterize the person that's been involved, the missing person. So that's a phrase you'll hear quite a lot about, the MP, the missing person. So characterizing that person, I need to know and work out what the specific gravity of that person. Are they floaters or sinkers? So all the things I need to think about are the size, the weight, the BMI, the clothing, especially heavy coats, denim trousers tend to sink quite a lot. And I found over time that what type of shoes they have on board are wearing is absolutely crucial. If you've got a heavy pair of shoes like this gentleman here, who's got boots on board, he will have a different trajectory than somebody who's just got, say, canvas trainers on board. Excuse me. Unfortunately, sometimes people who are committing suicide will add stones to their pockets. There was one case where an individual was actually watched going down the beach, picking up stones as he went and putting them into his coat pockets. But luckily he was recovered before he actually managed to get into the water. But these things do affect the trajectory on the individual. Finally, and this is a bit of a research area, we're looking at stomach contents, because this is one of the key factors in terms of bringing bodies back up to the surface. Microbacterial activity will over time slowly produce gases which will change the specific gravity of the individual and bringing that to the surface. So depending on what the stomach contents are, that can be either faster or slower. And this is one of the big unknowns. We don't have any good models of what's going on in the stomach contents and how fast the gases are building up. And so this is an area for research, and we're trying to work with Reading University to get a program off the ground to look at that. So this is trying to look at the different dynamics of a body in the water column. So first of all, you may have a floater, and that may stay at the surface for the whole period of the time. So this is somebody perhaps who's very light or has got not got any heavy clothes on them. They'll stay in the surface waters for all the period of the before they're recovered. So the second one is that they start off as a floater, and over time they slowly sink to the seabed and they stay on the seabed. So that's a second type. A third type is they go to the seabed, but then they rise back up into the water column, as I mentioned, by this microbacterial activity, and so they come back up to the surface. And then the fourth type is that they go straight to the seabed and come back to the surface with this microbacterial activity. And finally is that they may be heavy and they stay on the seabed throughout the duration. And I've seen all 5 different types of activity in the water column. Trying to generate the information and come up with a some sort of tool to indicate if they are floaters or sinkers is still on the research agenda side of things. So I'm still working on that one. So in terms of the challenge in the marine environment, we've got a whole series of issues. First of all is estuaries. Most of the people tend to go into the water in an estuary type of environment. And as we know, estuaries have a whole series of different characterizations in terms of their vertical structure and their dynamics. So you have vertically well mixed estuaries, highly stratified estuaries, well mixed estuaries, and slightly stratified estuaries. So these are the classic definitions of estuaries around the UK. And they're not just stationary. These things will be moving between different types if there's a whole series of changes in the drivers. So in terms of precipitation, there may be a lot of rain at one type, and you get a very vertically mixed type of estuary. But if there's low rainfall, you may change to another estuary type. So this is a major challenge for the modelling that we're hoping to do. Tides. This is something I expect we all know a lot about in our own areas. So this is just one way of showing the tidal ellipses in one particular area around the Greater Wash area. And this has come out of one of the numerical models. And what I'm showing is every 10th ellipse in this particular area. So you can see there's massive changes in the shape, the elongation, and the size of each one of these ellipses. On the coast, they're very rectilinear along the coastline. Further offshore, they're starting to open up. The ellipse is getting more circular rather than elongated. So that's a major issue. But the tides are one of the ones that we've got fairly good handle on. So it's not one of the major issues that we need to invest in. Second one is residual currents in different areas. So especially if you slightly get further offshore, some of these residual currents can be very important. So the Fair Isle current, for instance, off northern Scotland is a major driver of the residual circulation pattern in those particular areas. But as you see, they change as you head further south. There's one of the drivers, the currents can be a combination of the residual current and the wind direction. So you get things like the English River driving currents further offshore off the Flamborough front. So how can we join all these particular drivers into one particular model or tool? So we've been developing numerical models in Seefast for many years, and this is what we use and we consider to be probably the state of the art at the moment. We use models that are based on Telemac from the whole of the UK, and we have resolutions of less than 1 kilometre in lots of locations. So you can actually see on this slide here that there are predictions. These arrows, this is the Firth of Forth here in Scotland, less than 1 kilometre resolution all the way along the coast, and you can see how the headlands change and accelerate the currents along those particular coastlines. This is just one snapshot of what you get. So this is, it can be considered to be very much like a tidal atlas, you know. So these are something that's been used for many years, but at significantly higher resolution, both in distance. So on tidal atlases, so maybe 3 or 4 arrows across the whole of an estuary or the English Channel, whereas here we've got hundreds of arrows between the 2 coastlines. So significantly better estimates. They also, we can get them to work in 3D. So we have the vertical structure. So we also can add things like river runoff. So we have river runoff climatologies that we can add. So as we get in towards some of the larger estuaries, we can add in what we think the currents and are due to the precipitation in those zones. So that's getting more and more accurate. We also have very good bathymetry nowadays. The UKHO have got swathe bathymetry maps for virtually the whole of the UK in the key areas, so we can add those in. So we have really good predictions of the residual transport patterns and pathways. So that's our key output from the numerical models. And what we can do with that is we can then seed those particular flow fields with thousands of particles, so that we can get ensemble predictions of where the outcomes are or the projections are. So that's actually a key to what we're trying to do, is use this model. So getting into the details of what the model. So we have actually access to 2 major models. So we get outputs from the Copernicus system for a model called AMM15, which is actually produced from the UK Met Office. And is probably one of the best models out there for UK waters. So that's at 1.5 kilometre resolution. So that's really good. And then we've got the Telemac model, high resolution model. So normally when we have an instance, we have to decide which is the most appropriate. So the Telemac model tends to be really good at high resolution, but over time slightly deviates from the mean flow field. So we tend to use that for small short-term runs, where the Copernicus ones is very good for long-term residual currents. So we would actually try to go for that if it was further offshore, or and therefore we knew that the incident was going to take a lot longer to run its course. So first of all is model selection, and then data flow field selection. The second phase is model selection. So we have 2 major models that we use for this type of work. OSCAR, which is a well-known model developed by Syntev for the oil and chemical spill area, and we also use Cefas spill for hindcast predictions. So we know these models very well, and we can parameterize the use of individuals, if they're floaters or sinkers, in those models and run those models. And what we do is then feedback from the outputs of that back to our initial assumptions, so that we can check that our predictions are what we understand that the flow patterns are in those particular areas. So there's some areas that we routinely go back to on a routine basis, and we know what the flow fields are in those particular areas, and we use that to double check what we're doing. So what I'm going to do now is go through some case examples. I call this the good, the bad, and the ugly. So this is the good. So this is good predictions, correct in both in terms of location and in timing. The bad is the models predict, or the models are wrong in either the location or the timing. And the ugly is when they're both wrong and there's no outcomes which come up from the model, and I'll explain that a little bit further on. So case one, this is the Forth Road Bridge. So quite often we get the police search advisors, and these are the key individuals on the ground who are doing the discussions with the family, the Coast Guard, the operators of the bridges, and so these pulsars, police search advisors, are absolutely key, and developing a relationship with them is the number one thing to do. So they collate all the information that is needed, and I've got actually log sheets which I provide to the pulsars who can fill in as much as possible, which I can then convert that into the parameterization of the models. So in this case, good CCTV on the bridge, so the individual was identified going into the water, so there was good pictures of the individual, so the buoyancy could be estimated very well. In terms of the met conditions, strong wind fields and modest river flow. So this is the standard format that comes out of OSCAR. So you can actually see where the entry point is here. This hatched box. So that's the location of the entry box. And then I've run it. So this is the actual position of the stranding point. And the stranding point in these pictures are actually shown as green and yellow boxes that are actually on the coastline, and you can actually see the track of the body heading towards the coastline. So this is really nice one. I did the runs. I suggested to the pulsars that they stand down for 3 days and then go to that particular beach, and lo and behold, they found the person within the morning, and you know, they could close the case and get closure for the family. So that is the actual really good case example of everything working as it should. Sometimes you know, so that's really good. Okay, so the second case is in Plopton on Lough Corran, which is on the west coast of Scotland. This is a missing person after they've been into the pub for a couple of drinks, and then they're in their small little vessel, a little dotty boat heading back to the to their yacht, and they've fallen overboard. So we've all done this, and actually they came a cropper in this particular instance. So the buoyancy was estimated to be negative due to the, you know, heavy wet weather gear, boots, and clothing associated with the wet gear. And so I recommended in that particular case that they actually stood down for 28 days. It was in April, early in the year, so it would take fairly long period of time for the individual to come up to the surface. And that's what they did. So they actually stood down, and then they started searching a couple of days actually before, on the 28th, and they recovered the body and thought that the body had been ashore for about 2 days. So again, managed to get closure, and the police force hadn't spent a whole month searching around that particular highly complex area around the west coast there. So that's another good one. So next one is Kincardine Bridge, which again is on the further Forth. So this in this instance, the missing person left his vehicle on the bridge and jumped over the side, Again, they were estimated to be neutral in this particular case. And my numerical modelling showed that they should be heading down the estuary, and there's a large river runoff in this particular case. But after a few days, the actual person was recovered upstream of my point, so I was 180 degrees wrong in that particular case. And feedback suggested that they'd been caught on a tree or a bridge or something, and so there was selected tidal transport in one particular direction. So I don't get it right all the time. So you know, obstacles in the water column have been an issue in many cases, and quite often my assumptions are that I've got a smooth, concrete, circular estuary and not a meandering estuary with trees and roots into the main part of the estuary. So it's an issue that you can identify, but you can't actually do much about it. So that's one of the bad ones. And then case number 4, again, this Fourth Road Bridge, again identified by CCTV and estimated to be neutral, strong westerly wind field. And I ran it for this particular scenario and this particular time, and I got no beaching activity at all. So this particular person went straight down the centre of the Firth of Forth, not touching the sides, and the winds were such that they didn't push it in one direction onto the coastline or off. Now, you know, this is the worst case scenario all around. This is what we don't want. Not predicted. No predicted beaching. No closure for the family, and it's you know, the worst outcome possible. Now, there are a whole series of other issues that could be taking place. The body has been in the water for considerable period of time, and there may be changes in the buoyancy that have been going on due to issues called seal bite, and it is what it says on the tin, and also benthos attrition. So if they're sitting on the seabed, I'm afraid benthos will be you know, taking their fair share. So in this case, I was able to show that where we thought the body was, and the family of this particular individual were very happy that they could see where the person had gone, because you know, it was unfortunately it was an Asian individual, and you know, the embassy was involved as well. So they found that the police force had gone to the ultimate degree in terms of trying to model it, and so there was some sort of closure that, you know, that all particular outcomes had been explored in this particular case. So that's a fourth case. Also mention some quite high-profile particular cases that are being involved in. Some of you may remember the Gaia Pope case. This is on Swanage, when an individual was lost there, and one of the potential outcomes was that she had fallen into the water along that Dorset coastline, along towards King Harry Rocks, etc. And so I was doing a whole series of model runs trying to be where the police should be searching in those particular areas, assuming various types of location along the coastline. But unfortunately, you know, that was not needed in the end, because she was found actually on the land. So there was some closure there. And also the Libby Squire case. This is a student in Hull University, and so that involved also doing some model runs, including the River Hull itself before it discharges into the estuary. So I had to bolt that onto the model, use some transit times from where she went in down to the deep, which is where the whole river discharges into the estuary, and use that to drive the model. And I'll have to stop it there because the case is still live, so we can't talk much about that one. Okay, so backtracking. So this is another case, quite an interesting case. So this individual here was discovered on the beach at Perranporth in Cornwall on the north coast. So it was quite a mysterious case. So he was found only wearing a pair of socks and one shoe. So this is quite interesting case. So I was asked to do some backtracking predictions for this time and an individual. So I starting from Perranporth here, this is the exact location where he was found. I could show that he actually came from the south and west. So one of the potential entry points would be St Agnes Head, and also all the way down towards Portree, down a little bit further down the coastline. There was also some potential entry points there. So the police were able to use that to actually search some of those areas. Lots of little car parks situated in those locations, so you can actually search those places to see if he came from that. So it's another skill that you can use in these particular cases. Other cases in terms of backtracking, this is a classic headline, cocaine galore. So quite a lot of cocaine has come across the Cornish beaches over the years. So I did some more predictions there. And this one on the right hand, another right hand slide, is pineapple galore. So this is, comes from a case where we heard that 2 container loads of bananas and a container load of pineapples had come off a cargo ship, and I mentioned containers are quite often lost overboard. And this was at a position of approximately 25 west, 52 north. So this is virtually west of Cornwall, mid-Atlantic. And so I'm always keen to try and find where these things end up, so we can demonstrate that the models are working or not, and see which parameters we can change slightly to improve our predictions. So I made some advertisements in the local newspapers to ask if people found pineapples or bananas washing ashore, a bit like Fulton Mackay from Local Hero, if you can remember that film. And lo and behold, lots of pineapples did come ashore in the location we expected, but it was probably about a couple of weeks earlier than we had expected. So that was actually quite useful information. But what amazed me was that the local community started taking these predictions and as part of their drama clubs. So they were building plays around these pineapples and bananas coming ashore. So this is them with the banana costumes and pineapple costumes, exploring what the sea delivers at their foreshore once in a while. So finally, what does forensic oceanography do? What it provides is cost-effective and efficient search and recovery operations for the police force. So that's actually saving them money, which is saving the public purse. So that's got to be good all around. And what it's doing is ensuring closure for the grieving families. And I'm hitting around about a 2/3 hit rate at the moment, so that's good. But there is still a lot of room for improvement. So vertical movement in the water column, as you can see, is one of the things exploring a lot, and improvements in terms of the resolutions of models. There's an ever increasing appetite for improvements in models, so they're wanting to know which side of the headland, a body is coming ashore. What time is it? The morning or the afternoon? Well, with some of these models, I can give you windows, but I can't give absolute accuracy. in terms of the time. So what we're doing now is improving the resolution of the models. And this is just showing an excerpt from one model, which is from Brownsea Island in Poole Harbour here. And you can see the very high resolution models. So we're getting to sub 100 meter resolution in these models. And we're seeing the brown here is wetting and drying as well. So you're seeing very high resolution. So we can actually predict the movements in these sort of area with significantly higher success rate. Finally, the models also allow you to explore various hypotheses in terms of timing, entry points, etc. And I did this on another relatively high profile case, the April Jones case in West Wales. So that's another development which is still ongoing. Using in backtrack mode to predict sources of materials, that's narcotics and the like. So that's key to that type of case. Finally, I want to mention how this is actually funded. This is actually funded by a variety of sources. The key one is something called Cefas Connects, which is making sure that Seefast is relevant to the local community. And also DEFRA and MMO contribute to maintaining the models in the first place. So that's also needs to be acknowledged. Also, there's a whole range of individuals that have contact on a regular basis, and probably the most important is Murray Haynes, Inspector Murray Haynes from the National Crime Agency. So he's the National Search Advisor. But then there's a whole range of pulsars, ranging from Dorset to Police Scotland to Suffolk, and around the whole of the coastline. There's an audience probably there of 100 different individuals, and I thank you for working with me on these particular cases, and I hope to carry on in the future. So thank you for listening, and if you want to get in contact with me, do so on the Slido as normally on these particular instances. Thank you very much.
Lovely. Thank you very much, John. It's always interesting to see how these things can be used in kind of real life scenarios. So as John's just said, we do have Slido for your questions. So we'll spend the next 20 minutes fielding those to John. So if you do have any questions, please put them on there. Or we'll, if we do have to finish and there's still questions left, then we'll be happy to take those questions away and circulate those along with the link to the video afterwards. So I'll just quickly do one of the questions because I can answer that one. So someone's asked about whether this presentation will be available afterwards. Yes, it will. So after IMarEST will send a link round to everyone who registered, so you'll be able to kind of re-watch this at your leisure if there's anything that you wanted to kind of spend a bit more time on. So going through the questions, John, you'll be very happy to hear we've got quite a few.
Oh.
So the first one is, are there job roles dedicated to forensic oceanography, or is it more of a side part of an individual's wider role at Cefas?
It's the latter of those two. We use it as a training exercise to make sure that we're up to date in using the models, and the models are quite sophisticated, and there's many different parameters you can change, and you need to be sure which parameter you're changing rather than a one that doesn't help you in terms of better predictions.
Okay, thank you. And then, do you use real-time oceanographic data buoys in the missing persons tracking assessment?
No, we don't. What we use is the modelling, which is done in real time from Copernicus. So every 6 hours, I think, for that particular suite of data, there's new predictions, and they will be going out when we get those particular data sets. so that's both for the currents and also for the winds as well. So those will be going into the models. So that is an assembly of all of the real-time measurements out there into the models, and then we use the models themselves.
Okay, thank you. So are organisations using drones combined with your potential search areas and times for a more continuous search of missing persons or tracking of other objects?
Interesting you should mention that. There is a drone trial going on live today. There's a drone going up and down the Dover Straits. So this is the MCA doing these particular exercises. They tend to be using those for major incidents where you've got pollution impacts or there's an impact on the vessel integrity itself. So they tend to be for those larger ones. The police are starting to use more helicopter type drones around the coastline, especially where they're very difficult to get at cliffs or sea caves, where you can't get boats into those in a safe manner. So using a drone in those locations, but one of these helicopter quadcopter devices. So they are starting to use those. Yes.
Okay, thank you, John. We've got a couple more questions around about data, so I might just group those ones together. So the first one is, are you including wave-driven flows against the coast in your models?
Yes, Reynolds stress is included in the models, so they will be included in that particular one.
Thank you. And then, do you consider the importance of river inflow in estuaries? Could that be a contributing factor to errors in models in estuarine regions?
I did mention that we're using climatologies of river flows already. So we have, I think it's 4 different scenarios in terms of river climatologies. But getting the real-time information is starting to come through with various metering and gauging stations around the coastline and the river coastline. So that is something that we've got on our list of potential improvements to the model to give us better estimates in those estuaries where river flows can dominate those occasions.
Thank you. There are a couple more, but I'll just change tact a little bit and then we'll come back to the data ones. So maybe a more fun one for you, and it might have come up in the talk. What was the most interesting thing or scenario you have had to track, in your opinion?
Actually, it was one I didn't talk about, and it was the wood slicks, because that was 10,000 tons of wood, and it had very different properties than I've seen before. It tended to create these wood slicks, which would then have the front edge would be tend to be quite low in the water, whereas the back edge of the wood would be quite high, so that they would tend to create these jet-like features along the coastline. So if you look at some of the images of that particular area, they create these eddies and jet features, and so that was quite interesting. And we had to tweak the models quite a lot to get good estimates. Luckily, we were getting Coast Guard overflight information on a daily basis, so that comes in about 11 o'clock in the morning. We can do some runs for the next 48 hours, 72 hours from that, and then we get another update the next day. And then if we've over predicted, we'll pull back some of the parameters a little bit so that we can get better estimates for the following day.
Lovely, thank you, John. Is Seefast the primary source of search and recovery advice for the Marine Coast Guard Agency? And do you collaborate with other companies or organisations to do so?
We work closely with the MCA, and should mention the MCA are for search and rescue operations, so they're the primary organisation for that. But search and recovery, there are other organisations around the country, but I tend to get quite a lot of them. I'm getting them all from Scotland at the moment, and I'm getting a reputation for providing advice to various constabularies around the UK. But other people may have other favourite organisations they want to work.
No, thank you, John. Another personal one for you. How do you look after your own mental well-being with such tragic cases?
Yes, that is a very good question. And I think there is a sort of a humour that goes with it as well. And you get this from the pollsters themselves, who, they're the key individuals. And, there will be, some, chatter going on about, individuals who do stupid things in stupid locations. And, I think it's the camaraderie and the humour about the situation that, tries to alleviate those particular problems. But yes, a major issue.
Thank you. The next one starts off with great talk. Do you think we should be using stories like this to improve ocean literacy and to inspire people to go into oceanography, or is that something you already do?
Well, this is the first of this particular type of presentation, because it is a hard presentation to give in terms of making it interesting enough to a wider audience, and at the same time not making it too grisly. So you've got to make it about closure and helping individuals and families in their grieving for their lost one, and also both a scientific challenge and also a helping public services. So there's a whole raft of issues there that you can talk about, but it's not something that you would expect to get in a talk for 16-year-olds in their local school. Death and bodies is not something that they're going to be particularly interested. But if their family were involved in it, yes, they would be. So there's some sort of balancing needs to go on there in terms of making it interesting and applicable, but at the same time responsive and respectful to the individuals. Yeah.
But potentially you could focus it on the backtracking things such as the pineapples and the bananas, or as someone's mentioned, the Lego bricks, which is a new example.
Lego bricks, container, Nike shoes, there's a whole raft of them. There's also lead bricks from a ship in the off Cornwall. So yeah, there's a whole range of targets that have been identified over the years, and people look out for. There's websites that will be predicting or showing the latest bit of Lego that they found, or how many black octopuses they found. This is a Lego black octopus you can get in the kits apparently. So they're the prize ones.
I think I used to have one when I was younger. But we've got some more data questions now. So I'll read them individually, but I apologise if they are linked afterwards. So the first one is, have you found AMM15 an improvement over the 7-kilometre resolution AMM7? Was AMM7 useful for search and recovery?
Oh, very. The 15, the AMM15 is significantly better than the AMM7, and they absolutely very useful, and we use it on a regular basis. The AMM7 didn't resolve the key headlands and the key estuaries at all, so wasn't that particularly useful in that particular instance. But the AMM15 I can recommend.
So on the AMM15, someone's asked, is the model resolution and output frequency good enough?
What I would like is variable resolution, so higher resolutioning around the coastlines themselves, so you know, for instance, Southampton water would be really useful to have in those particular locations. In terms of the time step, that's fine, but it is the resolution that Southampton water, the Thames Estuary, you know, these are the key areas with high risk locations for people entering those areas, and industry itself, you know, Forley Power Station, for instance.
Lovely, thank you. The next one is the SynTef Oscar model proprietary, and why do you use this particular model rather than equivalents such as open drift?
Yes, we use the SynTef one because it's one of the most recognized ones in the world. There's a couple of different other ones. There's open drift, as you mentioned, but there is also ChemMap from another developer as well. So there are different modeling systems out there. The reason we use Oscar is, as it's the one that we're providing advice on, we need to have training to make sure that we're up to date in using it. So there's quite a lot of, there's a chain of things you need to do. So making sure that that chain is up and running, you know, 24/7 is an issue. So making, I don't want to go into too many different models if they're not the main ones that we're using in-house.
No, that makes sense. Thank you. What happens when any drugs are transported illegally via the ocean? How can those be red-handed?
How can they be red-handed?
Yeah, I was hoping you might know that term. But I suppose what happens when the drugs are found on the coast?
Well, they would given the local constabulary would be involved, and the drugs unit would be finding the particular location of those. We also mentioned there's NIMIC, the National Marine Information Centre. They will have an interest in what's going on in these particular areas as well.
Thank you. So thinking about the past now, can your systems be used to predict where bodies may have ended up from shipwrecks from the past? Of course, only based on weather and tidal information of the day.
Absolutely, as long as we can get information on the date and the time, and we can predict what the currents are. Yes, I'm not sure. I haven't tried to go back, you know, to various very long period model runs, but I've done them from 10 years ago, using, you know, going back from information that we've got nowadays. You know, there are, yes, I'll stop there.
Okay. So there's only two ones left, and they're more comments than questions. You'll be happy to hear unless any more pop up. So the first one, thanks you for your presentation, and just is letting you know that they're assisting with a missing person search near Portland. So they're making sure that they definitely have your contact information. So thank you very much for leaving it up there, because it sounds like they're going to be in touch. And the next one is probably going to show my youthfulness a little bit, because I've no idea what they're talking about, but I'm hoping you probably will. So they've said maybe this could be incorporated into a long overdue remake of the classic 70s public information film Lonely Water. Do you know what that's?
Lonely Water. I can remember a local hero, you know, with Fulton Mackay and on the beach, you know, but not that one, no.
Oh, well, I'll have to go away and do a Google afterwards.
Yes, absolutely. But if it's, I have been involved in a case near Portland recently, so with Dorset Police actually, so there is a link back probably to that one as well. Okay,
thank you, John. They were all the questions. So I'd like to thank everyone for listening, but thank you very much, John, for giving your talk. It was really interesting, and like I say, it's a very different side of marine science that people get to see. So thank you very much.
Thank you, and thank you for listening.